Hi, welcome to 3D Animation Enya. I am Autodesk Maya online teacher. Today we will create n-particle metaball drops on a plate and use tools like motion path expression editor for animation and apply surface wrap and soft body for blobby effect. Okay, let's start. Go to FX module, n-particles menu, n-particle tool near the world center, that is 000. Create this n particle around this world center. Use grid snap. You won't be able to see it, I feel. Once I create the cluster, you will be able to see it. 2, 3, 4, and 5, 6. So 6 particles, n particles we have created. Press enter. So now it's one single family. This n particle one node is having 6 points. That is 6 metaballs we are going to convert it to. So now first we have to create the clusters. Go to component mode. This is the first one we created. So right click on it, go to particle mode, and you'll be able to select it. This component should be on, only then we'll be able to select individually the particle mode. So now you can see it yellow color. It is in yellow color, means it is being selected now. So now I will go to rigging module, deform, cluster. You can see this C letter on that. Now this is the second one we created. Again go to particle mode, select it, will become yellow. Now again go to deform cluster, like that for other particles also we will be doing. Select it, deform cluster, select this one, deform cluster. So 1, 2, 3, 4 particles are finished. Now 5 and 6 are remaining. Particle mode selected, cluster, yes, this is the final one, cluster. So totally you can see here 1 to 6 clusters are there. This is 1, 2, 3 and 4. This is 5 and 6 finally. Now we have to convert this n particle node to polygons. Okay, go to modify, convert n particles to polygons. Right. Now it won't immediately show up, so we have to go to attribute. There some modifications we have to do, then it will show up. Now we will rename this as metaballs. Go to attribute, so there your finding this n particle shape. This is the one we have to go. Now you will see under this n particle shape one, you will find this output mesh subtab. Press on it, it will open up. Now we have to change some values. Once we change it, you will see the polygons getting created out of those points. Now I will type these values. Threshold can be 0.1, that is default, that is okay. Blobby radius scale should be 6. You can see the polygons are getting created. Slowly you will see its behavior, what the nature of metaballs. You will see its behavior. Motion streak is 0 and mesh triangle size is 0.1 and maximum triangle resolution is even 100 is okay, and mesh method is quad mesh. Okay, here iterations should be 4 so that it becomes smooth. Now you can see it is merged. This is the nature of metaball. Once I bring it out, see how it is behaving, and if you bring it near, it becomes one single object. So this is the nature of metaballs. We can use this for mercury and blood cells and any biological projects. If you are doing or chemistry projects, for those things we can use this metaballs. Now I'm just showing you a sample. Now we have to animate this clusters. So let's go. First we will create a floor. We'll create a disk. It's okay. Go to front view and keep it down. Right. You can switch off the grid. Now if you see, it will fall because of the nucleus, that is gravity is on. You can switch off the gravity. Gravity 9.8 is there. You can switch it off. Now it won't happen. Then we have to create a path for the clusters to get animated. So go to wireframe mode and create polygon primitives helix. We want a spiral path, so we are going to extract the spiral curve out of this helix object. Okay. Height should be more so that we can see how many turnings are there. Width also should be more. It's okay, it doesn't matter. Coils can be 2.5, that should be enough. Now go to edge mode. This soft modification is on, so we have to switch it off. Again we will switch it on when it is needed. We will switch it on. Go to edge mode, select it, select the curve, go to modify, convert polygon edges to curve. Now we don't need this helix object, you can delete it. Select the curve, apply history, delete. Yes. Now we have to make uh, that is the top portion should become small and the bottom portion should be big for the curve. For that we have to go deform lattice, go to lattice point modification, make it small like this. You can see the curve is becoming small and the bottom portion of the curve is bigger, even more bigger we can make it, right? Now the work is done for the lattice. We can select the curve and edit, delete by type history. Once we apply history, the lattice will go off and the curve will get the change whatever we did with the lattice. Now we have to apply 0 in the scale Y so that it becomes flat. Now go to front view and just check whether we should align it or not. No, may not align it because the clusters are here, you can see, and the curve, the path on which we are going to animate these clusters are in the same line, so we don't have to move it, let them be there only. Now rename this as path 1, duplicate it, and one more path is needed. That is, path 1 is for cluster 5 and path 2 is for cluster 6. Okay, so path 2 we have duplicated. There is only one difference we will make, is it comes from the opposite side. For that we have to apply -1 in the scale X. You can see from here it starts, this path starts from here, so this is how we want it. Now select the path and apply curve reverse direction, so that when we animate the clusters, it starts from the outside and ends in the middle. That is what we want it. So we have reversed the normals for the curve. Now, sorry, we have reversed the UV for the curves. Now, small changes we have to do. That is, when it is going to end, it should be little away from the center. That is this world center. So the curve ending should be away from the world center. Once we assign the cluster 5 to path 1 and cluster 6 to path 2, we will do that change. Okay, so now select the cluster 5 and select the path 1, go to rigging, constraint, motion paths, attach to motion path settings, time slider. That is, time slider is 1 to 200, same we can keep attached. Now you can see along with the cluster, this ball is also getting illuminated. You must be remembering that when we created the cluster, after creating the end particle, we went into particle vertex mode and we selected each point in the particle and created cluster. Once after converting that end particle to mesh, when we move the cluster, the mesh is also moving. This is what we want. See how beautifully it is merging with its family other particles. Okay. So let's animate the cluster 6. For that, select the cluster 6 select the path 2, go to constraint, motion paths, assign the path. Yes. So like this we want, and we don't want this much distance to be covered by the particle mesh. So what I'm going to do is I'm going to apply expression editor. Okay. Select the cluster, any cluster you can select. Now go to expression editor, Windows animation editor, expression editor. So in that we have to select the motion path. So for that, if you see this this metaballs, if I select in the attribute editor, you will see motion path 1 and 2. That is for cluster 5 and 6. You will see motion path 1 and 2. For cluster 5 motion path 1, and cluster 6 motion path 2. This node we have to find it in the outliner. So for that, go to outliner, switch off the tag objects only. Slowly you will scroll it, you will see motion path 1 and motion path 2. Those nodes are here in the outliner. Only if you switch off this tag objects only, you will be able to see the motion path 1 and 2 nodes. Right, now you select both of them, go to channel box, you will see something called U value. Select it and right click, break connections. Now you can apply expression editor. Select the motion path, you will see, once you select the motion path, you will see this object's motion path 1 and its attribute. This is called attribute. You are seeing this attribute here. So select this. Now we have to take notepad. So this is the value we are going to type. Okay, with some changes we will be doing. So here you can see motion path 1, motion path 2 dot U value. This U value is the attribute, is equal to sine. Sine means it's a wave function. Okay, it's a math function. It is, we got that sine from here. You can see it in the math functions, in the expression editor, under the menu insert functions, under math functions, you will see this sine D, and maths. Many such functions are there, cos function, tan function, all those functions are there. Now today for this we are going to use sine function only. So let's copy this and paste it. So here let's type from here I want, that is, I don't want this cluster to come from, start from here and cover the entire path and end here. I want from the middle only it should start, so that I will get it can the ball will move very slowly. It should not move very fast. So for that purpose we are using this expression editor. So let's change the value to 400. 0.8. That is 0.8 means this is 1. This, the starting part is 0, and the ending part of this curve, that is this path, here it comes actually. You select this. This is the starting point, as I told, 0, and here it ends like this. It comes and ends here. It is 1. So I want from the middle, it should start and end. The ball should start from the middle and end. So the middle we can assume as 0.8. Okay, 0.5 or 0.8 we can assume. Divided by 400, 100, 200, 300, 400, why we are typing is it becomes very slow for that. Otherwise, the sign will move it very fast. To and fro it goes. So to make it slow, we are typing 3-digit numbers like 400, 500. So let's try this. We may have to change again. So you can see this is the syntax, that is machine language. We have to follow this. This is the object name, attribute, it's equal to sign, bracket start, bracket open, frame divided by, that is frame is 1 to 200 is a frame, divided by 400. So it becomes half the speed. Okay, into 0.8 is that is not info, sorry, plus 0.8 is from 0.8 it starts towards 1. Okay, so here also point plus 0.8 at the time. Now create it. Let's see how it is. See, from the middle only it is starting. It is in the first frame. From the middle only it is starting, and it is ending. And so this expression editor work is over. We can close it. One small change we have to do in the path, and that is go to vertex mode, select the vertex. I want to move this, go to top move. I want this portion to go little away from the center. So for that, if I move this, only one, so many vertices are there, so I cannot move this entire portion. So for that, I am going to use soft modification tool. Once I have selected any vertex, I will go to translation, tool settings of translation, and in that dialog box you will find soft selection. It's called soft modification tool. Switch on the soft select, close it. Now if you see it, it moves proportionally. That is, this yellow color is strong movement and red color is very not much affected. You can see that. So this is what we are trying to do. Now you see that is ending. See, you keep it here, right? Now select this path. Same, we will do this for this path too. So this ball should end here, and that ball should end here, right? Now let's animate and see. Right? And extend the frame and see. Okay, 250 will keep. Okay, little gone too away from the center, so let's change it back to here. It should not, the blend we should be able to see the blend. See, this is out of blend, this is inside the blend. This blend we should see. Okay, do the same for this part too, right? Now we can switch off the soft modification tool. Rewind and animate, you can see. Yeah. So now we have animated the balls globally. I want the shape also to get animated. For that we are going to use surface wrap and soft body. Okay, for that you have to take a polyplane, scale it up, type subd width and height 4. Now we are going to apply the soft body for this plane, polyplane. After that, this polyplane becomes a wrapper. There is surface wrapper, a wrap deformer, and this metaballs becomes a wrappy deformer. Okay, so let's first apply soft body for this polyplane. Go to rigging module, deform, go to effects module, end particles, soft body, go to its settings, edit reset settings, make original soft. Okay, and switch on these things, create. Now it will disappear. Once you rewind it, it will appear again. You don't have to worry. Now if you play it, nothing will happen to it. Now because a particle needs a force to get moved, like air or wind, like that, wind or turbulence, like that, some forces are needed to make it move. So we are going to apply turbulence. Okay, now select the particle. You will see that particle is being created under the polyplane which we selected and gave the soft body. The particle will be inside inside the hierarchy of the polyplane. Okay, you can change the polyplane as wrapper or wrap deformer. Now select the particle under it, go to fields. You are seeing the turbulence, apply it. Now change the magnitude to 30, attenuation to 0.1, and frequency is 20. That's enough. Now rewind and play it. Yeah, this is what we want. You can see the wobbling effect. Nice. It's kind of wave only, but it's going to create the wobble effect for these balls. Okay, rewind it. Now we are going to apply the surface wrap. First we have to select the metaballs, which is the wrappy. You can name it as wrappy. Then select the wrap deformer, that is the one who is going to influence the wrappy, that is metaballs. So first I selected the wrappy and then wrap. Go to rigging module, deform, wrap deform. Now if I select the grid and move, it will move along with the grid. So that is the effect of wrap deformer. And if you move the grid vertices also, it will get the metaballs, that is the wrappy, will get affected. Now if I play, you will see metaballs bubbling or wobbling effect. You can see it. Before applying the wrap deformer, only falling plane was having the wave effect or wobbling effect. Now once after applying the wrap deformer, these balls also having the same effect. We don't have to see the polyplane in shade mode, so we will change it to freeze. We will freeze it. Okay. Go to display, object display, template. Yeah. If you want, you can apply more turbulence, like 40, like that. Okay. Now we shall apply some shaders. We can hide these clusters and curves, this part. We should not delete them. You can just hide them. This we will rename as plate or something, or floor. Okay. Now first apply the shader for these metaballs. Go to Windows, Rendering, Hyper Shade, create shader surface, standard surface, select the metaballs, assign material to selection, double click on the shader, metaball shader, rename it. Now I want to give it red color only, and give it little of metalness. 0.1 should be enough. No roughness should be 0. Okay, this also 0. Specular roughness also 0, and IOR, that is index of reflection, should be 1.6. Nothing else. If it needs, we can give quote, but let's see if it is really needed. Can be in different color, but let's see how it works. Okay, now we have to create a light, area light, scale up. Paint it. Okay, and switch off the normalize in the light. Now go to Add-on Render. Yeah, it's nice. This is still render. one single image render. Once you render it as sequence, it will look very nice with the wobbling, the bubbling effect, all that will be there. So it will be nice. Okay. You can apply some shader for this also. Assign new material. Standard surface. Like this also will try as metal. No roughness. Let's see how it looks. No, it's not really nice. Normal texture would be okay. Yeah, it is okay. And for the metaballs, we can try transparency too. You can just try it. Like go to transmission and increase it. So this is how it looks. And we can just keep on working on the colors. It takes time. Rendering, see, it's 29%, 37, like that for every frame. It is totally 250 frames. Every frame will take 20 seconds. So we can calculate at least 1 hour it will take to render. So in this video I cannot show the sequence. Now I can just move my frames and yeah, you can see the bubble effect. It's not purely spherical. You can see it as the shape has been changed because I moved the frame slider here. You can just move it. Okay. See how it behaves. So in the render sequence, it will be like very new. Nice it will be. Play it, and then the last frame we can render and see. Right. For particles, we should not move it like this. So let's do the cache and then we can render. Okay. Select the particle, go to effects and cache, create new cache, n object settings. Here m balls means metaballs. Here also m balls is there. Create. Is asking for replace existing auto rename and all. Already I have done this same exercise. So the file is already there. We can replace it. Now it is caching, means recording the every vertices positions. Okay. So once after caching, we won't have the problem of this crushed effect. Okay. Now it's done, I think. Yeah. See. Now if I move this, it will show the actual frame. It won't show the crushed effect. Right. So cache is very important. Right. I'll put it in wireframe on shader so that you can see it. See how it is behaving. Okay. Tendency. Sometimes render won't get updated. We have to close the render window and again open it. Only then it gets updated. I feel we don't need transparency, so let's remove the transparency for the waterfalls. Transmission 0 and what else? Even code we don't need. Specular and base should be enough. Okay guys, that's it for today. You can visit my website 3danimationyagna.com to know about my online classes and YouTube links. Please subscribe my channel to see more videos on Maya software. Thanks for being with me. Cheers.